Hello students, welcome to Misostudy video classes and hope you started enjoying these initial topics of class 11th. As you know, you just entered in your class 11th and you are finding physics slightly difficult, lot of new things. So in initial videos we tried our best to make things simple so that you can understand. Now as you know, and obviously if you are revising, you will definitely have that understanding of various mathematical tools that we discussed in the previous videos. It was like integration, differentiation, and you can say putting limit values, fine. So these type of things. Also we discussed the topic of vectors, fine, how exactly you can multiply, divide and all these things. So today, as you know, we have already started this chapter, that is kinematics, fine. And this chapter kinematics, and what we are discussing in previous topic, if you try to recall, we explained you various initial parameters and characters. Characters in the sense, one character was velocity, another character was acceleration, displacement, distance, all these things, fine. So today we are going to start a new subtopic under this heading, fine. And what is this new topic? That is relation among variables. Actually, what are the variables that we discussed till now? So all in all, we explained three type of characters, three heroes, fine, of this movie. One is your displacement. Another one is velocity. Both are vector quantities. And then you have acceleration, fine. Now basically we want to establish a relation in these properties. What is the relation? Now why we want to develop a relationship? In class 9th, you studied these three relations. Those were V is equal to A U plus AT, U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus twice AS. But in class 9th, we achieved these relations using graphs, fine. But now we are not in class 9th, you are in class 11th. So obviously you want to learn some higher order thinking techniques to find out these relations. So we will try to drive these relations using our understanding of differentiation and integration, fine. Now no graphical method, fine. So all in all, this is something displacement which is in general represented as S, and it is a vector quantity. Then you have velocity, so U or V, that is in general the way of representing velocity like this. And then acceleration, yes, this one, or acceleration due to gravity, G, fine. Now if we would like to put some numbers, I mean name 1, 2 and 3, fine. What I would like to mention over here, what exactly we are going to do under this heading? We are going to learn the technique or method how to drive these results. Now this is something that is very important for your school exams. Normally out of these three, definitely one derivation they will ask in school exams, and understanding of these relations is also very essential till your competition level if you are thinking to appear in engineering entrance exam or medical entrance exam. Fine. So, I would like to mention over here one simple aspect that you can say driving 1, 2, 3 using integration, differentiation. Fine. So, basically now we will use integration, this one, and differentiation. These are two methods that we will use. That is why if you try to recall, in initial classes I explained differentiation, integration, how to put limit, upper limit, lower limit, upper limit minus lower limit, that will give you final function values. Okay. So, now let me allow to clean up this entire green board for you, and then one by one I will explain how you can drive these relations. There is a specific pattern of driving these relations. You just take a look properly and then you will find yourself in a very comfortable position. Whenever out of these three equations they ask any, fine, your starting should be from this step. That is, I am explaining in a very proper fashion. If required, you can skip some steps. Fine. Let a particle is moving with constant, I am not saying anything about velocity. Let a particle is moving with constant acceleration. Fine. So, what we can say? We can say acceleration A is equal to rate of change of velocity with respect to time. And this is something which I am explaining for your understanding. Fine. You can in examination, if they ask, it is not always essential or required to keep it like that. You can make it in a shorter form. Acceleration A is equal to rate of change of velocity with respect to time. Fine. This is the simple explanation of acceleration. So, what I can say? I can say A is equal to dv by dt. Now you can realize why in the starting classes of these videos I devoted good amount of time in the explanation of integration and differentiation. So, now I hope you can understand, that is, change in velocity, small change in velocity with respect to time is something which is defined as acceleration. Okay. So, from here if I want, then I can write it like this way, that is A dt is equal to dv. Fine. And then our well known this snack like symbol, that is integration. Integration. Fine. This is lower limit, this is upper limit. Sorry, lower limit, this is upper limit, this is upper limit. Now, let us start the journey from this yellow color equation. Basically, the journey should start from here, but I mentioned these points just to give you the understanding. Fine. So now let's move ahead, and that is a dt 0 to t. Why 0 to t? Okay. Actually, in physics, that is an experimental stream, what I mentioned in initial classes, if you want to measure the time, you have to start your clock at some point of time. So, moment I will start watching my clock, so that particular second or that particular instant is considered at 0. 0 means starting. So, initial is 0, now my clock is starting, like that. And then I am taking observation till a time t. Let us say for this time it is like 0. So, after this much, now it is 3 seconds. So, 0 to 3, something like that. Okay. So, and here if you do not put this vector sign, no problem for the time being, because here we are just trying to find the relation. Fine, there is no specific reason of keep on putting the vector sign. We know that acceleration is a vector quantity. Then about velocity dv, it is u and v. Initial velocity u. Let us say I started this experiment and initially my small object m, that is mentioned over here, is started moving with some value of the velocity. So, that is initial velocity is u. Now, on the basis of our understanding, fine, if I am writing at is equal to v minus u, you will say no problem, upper limit minus lower limit, and then gradually we can solve it. Here u is initial velocity and v is final velocity. So, u is something at starting time t is equal to 0, when you just started your observation, and v is the velocity after some time t. Fine. So, now from this relation, what I can write down over here, that is v is equal to u plus at. I am writing directly, put it over here, then v and then these things. So, do not you think this is class 9th equation number 1? Fine. Now, if the object is moving in vertical plane means what? Under the influence of gravity, then this same relation will be replaced u plus minus gt. Why plus minus gt? Because if the object is moving upward but g is downwards, so it is minus. If the object is moving downward, g is also downward, so it is plus. Now, this one equation is you can say giving me a relation between initial velocity, final velocity, acceleration and time. Okay. Now, the second relation, so let it be here, this relation let it be here, and what I will do, I will clean this remaining portion and then start moving ahead. Fine. These things are very simple, anyway not difficult as such. You just have to practice few times and then you will start enjoying all these derivations and relations. So, do not worry on that part, it is anyway not a difficult aspect. So, now I have a relation, that is v is equal to u plus at. Okay. Now, here u constant. Why? This question may come in the minds of many of you. Because when I started observing any object initially at time t is equal to 0, so this velocity is fixed. Okay. Now, a constant, this is I mentioned in the starting, and if acceleration is not constant, you cannot apply Newtonian mechanics. Whatever you are discussing, acceleration is constant, it is not changing. Fine. So, for v, if I am writing ds by dt, you can say no problem. Why? Velocity is what? Rate of change of displacement with respect to time. Okay. So, I would like to mention for your understanding, rate of change of displacement with respect to time. Okay. No problem. So, what I will do in this equation number 1, what I will do, at the place of v, I will write down ds by dt. Okay. So, let us move at this place of this green board, and let me allow to mention it as ds by dt is equal to u plus at. No problem. Now, ds is equal to u dt plus at dt. Simply multiplication. Fine. Now, let us integrate. Okay. Now, easily you can say this u is a constant term, so we can put it outside. This is something that I explained during the explanation of this what integration method. This a constant, very specifically I mentioned over here, so you can put it outside, but t is not constant, t is changing. Okay. So, now let me allow to mention the limits. 0 to t, 0 to t, and let us say this is S1 to S2, but I think best is to write it as 0 and S. Why? Reason is simple. When I will start this observation, the object will start any point. Let us say that is origin, and then the object is moving. Fine. So, I explained you this is also a method of writing. Then here you can say is equal to 0, origin is equal to S. Fine. So, now when I will integrate ds, I will get S. Okay. S is equal to u, and dt means t, limit is t. So, ut plus half at square. Now, in this integration, if you are not regularly revising our previous videos, obviously you will find, few of you will find it difficult, but if you try to recall, this is something which I very specifically mentioned during those videos. Fine. So, S is equal to ut plus half at square. Don't you think it is my second relation, well known second relation, old friend? Okay. Now, I will use that space to write down something. Please be with me, come at this place. So, one relation I achieved as S is equal to ut plus half at square. equation number 2. Also, in case of gravitational aspect, I can write it as H is equal to ut plus minus half gt square. You can say equation 2 prime. Now, plus minus, as I explained in this particular relation, so we can easily find out. Okay. Now, what we will do, from equation number 1, we will take the value of t and will put this value in equation number 2. Fine. Take out the value of t from equation number 1 and put it in equation number 2. Then we will try to find out what exactly we are getting. Obviously, the idea is simple, to get the third relation, and I will definitely write down that. Fine, without any type of simplification, because this is something which is quite simple for you to understand. So, with this I would like to move at this place in order to achieve our third relation, that is by putting the value of t from equation number 1 in equation number 2. So, this time I will explain you near this portion. Just take a look over here. By putting the value of t from 1, by putting the value of t from 1 in equation 2. Okay. So, equation number 1, this purple color equation, equation number 2, this white color equation. So, by putting the value of t from 1 in equation 2 and solving, fine, what we will get, that is v square is equal to u square plus twice as. Fine. So, I will also mention this equation at this place, that is, and this is so simple that I do not think there is any point of putting the equations values and solving it. So, it is v square is equal to u square plus twice as, equation number 3, or you can say v square is equal to u square plus minus twice g h, that is 3, equation number 3 prime. So, now students, I explained equation 1, equation 2, equation 3, how you can derive these relations, simple integration, differentiation, and also I mentioned the counterpart of these 3 equations in case when the body is moving under the influence of gravity. Fine. Now, after this you may ask, what is the use of this? Obviously, the use of these tools is enormous. So, I would like to start just with the help of 1 or 2 simple examples. Fine. Now, consider a situation. Let us say I am standing on the top of the Qutub Minar, a historical monument that is situated in capital of Union of India, Delhi. Fine. Let us say the height of this historical monument is capital H. Okay. Now, from the top of this tower or Qutub Minar, I am throwing a ball horizontally. Okay. Horizontally with some velocity, let us say for example u. Okay. This is case number 1. Fine. Another thing, next time I am doing from the same top of the Qutub Minar, although it is not allowed to reach over there, but just an thought experiment. So this time I am dropping a ball downward. This red color arrow is drop a ball. This is case number 2. Fine. So initially we will try to analyze these 2 cases. Okay. I can also accommodate one third case, that rather than projecting the ball horizontally or dropping it down, but I am throwing down. But let us wait for that. So what is the difference in these 2 situations? What is the difference in these 2 situations from the point of view of these 2 equations? Fine, that I am going to tell you. That is a concept. Right now I am not going to solve any numerical anything else. So let us say this is case number 1, this is case number 2. Fine. So what I am writing? I am writing case 1 and case 2. Initial velocity downward is 0. Few of you may be slightly shocked. Is it like that dropping means initial velocity 0? Yes. Drop it. So moment it starts moving down, initial velocity nothing, 0. And for this white color arrow, I am throwing the ball or object horizontally. So downward velocity is initially nothing. It will start moving downward because of the presence of acceleration due to gravity g. So because of that reason, you can say yes, it is moving in this direction, but initially downward. Is there any velocity? No. So both these cases are similar. Fine. Now if you have to solve any problem from these type of concepts, you can apply, you can move in this fashion. Fine. Let me explain you another situation by rubbing out this situation. And what is that situation? That I will tell you. Now let us say from the same Qutub Minar situation, listen carefully. I dropped a ball, drop a ball. Just imagine. Now what I mentioned, initial downward velocity is 0, okay. So this ball will start moving under the influence of gravity small g. First fact. Second fact, will this ball travel equal distance in equal time? No, because this motion is accelerated because of g, acceleration due to gravity. So one conclusion that I would like to mention over here is, this ball will, these points if you keep in your mind, which I am explaining in initial phases, you will find yourself in a very comfortable position when you start solving numericals. This ball will not travel same distance in equal time. Why? Because the ball is moving under the influence of gravity g. Fine. So you have to apply the equation v is equal to u plus gt, because it is moving downward, and u is 0. So v is equal to 80. Fine. After some time it is going to be v next is equal to v initial plus gt, and so on. Fine. So this one is one situation. Now students, there is enormous use of these three equations for solving n number of situations. N number of situations, I am not saying numericals. Obviously we have to cover a lot of numericals just to give you the understanding. Okay. Now before ending this lecture, I would like to mention a very important aspect over here. In this particular discussion, the acceleration is constant. Fine. But when we will start discussing motion in a plane or circular motion, acceleration will remain constant in magnitude but not in direction. And you know, as I mentioned also in previous videos and today's video, that acceleration is a vector quantity. So therefore, if not only magnitude and direction both if are not stable, not constant, then the vector is not constant. And because acceleration's magnitude is constant but direction is changing, so here acceleration is not constant, and in that situation you cannot apply these equations as it is. You have to change them. How? That we will discuss, that we will learn, that we will see in coming videos. So over here whatever I explained you is so important for your preparation from all aspects that you must not neglect it. You should not, you can't afford to neglect it. So the simplest possible manner, the way I explained, I simply would like to request all of you, keep revising, let's do some work over here to get the understanding, and you will find yourself in a very comfortable position. So with this I would like to close this discussion over here. Very soon I will come back with some new videos. Till then, take care of yourself. Have a nice time.